This is the last video of the day, I promise. But this introduces what we're going to talk about tomorrow. So let's begin with a system that's not triangular. And I'd like to show you how we're going to reduce it. And there are some details here, some structure that you want to pay attention to. But here is the system, 3 equations, 3 unknowns. Let's reduce it to triangular. And what I will do in the first step is I will use the first 2 equations and eliminate the x1 in the second one. So to do that, I'm going to take minus the first equation, minus the first row, and add it to the second row. And this is what I was talking about. This doesn't mean add them together. This means add to. Minus this, added to that. And at the same time, I'll take minus 2 times the first row and add it to the third row. That will eliminate the x1 and the x1 variable in both of these. So let's take a look at it. The first row remains the same. Because nothing was added to it. The second row becomes minus the first row plus the second row, no x1s, minus this plus this is just plain old x2, minus x3 plus no x3s is minus x3, minus 1 plus 3 is 2. So the new second row becomes this. And we've begun to reduce it, reduce the system by having no x1s in this one. We also want no x1s in the third one. So minus 2 times x1 plus 2x1 is no x1s. Minus 2x2 plus 2x2 is no x2s. So we get rid of the x2s in that case. Minus 2x3 plus x3 is minus x3. And the result, minus 2 plus 1 is minus 1. So this is our second set of equations. This is almost triangular, just one more step. The last step will take minus row 3, meaning you take the equation 3 and multiply through by minus 1. That will be a solution row for x3. And the net result is x1 plus x2 plus x3 equals 1. x2 minus x3 equals 2. And x3 is 1. So this is the solution. This is the triangular reduction. And this is exactly problem 1A of the worksheet from Monday. So now that we get this, we can get the entire solution. There is a unique solution to this, and we found it in the last one. And right now, I forget exactly what it is, but we know how to solve this one. It has a unique solution at a particular point. What I'm looking at now is this reduction process. And in this reduction process, several things are really not needed. Here we've kept all of the variables in columns. And so rather than use the x1s and write those down and the pluses showing we add, we'll just write the coefficients. 1, 1, 1. And then the constant term is 1. I'm going to put some dots in here to indicate that we're not just looking at the coefficients here, but we're also looking at the constants on the other side, and there's an equal sign in here. The second row will be 1, 2, 0, 3, 1, 2, 0, 3. And the third set of coefficients are 2, 2, 1, and 1. And I'm going to bracket this off to indicate this. Now there are 3 columns here that represent coefficients, X1s are here, X2s are here, X3s are here, constants are here. And just the position is going to indicate that those are there. Then in the reduction process, we'll get a new set of equations, this set of equations. And in order to get those, we do these operations, minus row 1 added to row 2, and minus 2 R1 added to row 3. When we do that, we get a new array. These arrays are called matrices. And the entries will, again, on the left will represent the coefficients of the x's, and on the right will just be the constants. We could copy them down from here, but let's just do it. Minus row 1 added to row 2. Well, the first row remains the same. Nothing gets added to it. The new second row is minus this plus this is 0. This 0 indicates that there is no x1 variable in that equation anymore. Minus 1 plus 2 is 1. Here we get a minus 1. And here we get a 2, corresponding exactly to the coefficients and constants of the second equation. And then the last one is 0, 0, minus 1, minus 1. So this is our second array. I'm going to erase the equations now and just work with the arrays. For us, there's one more step. Just looking at this, we want to get a 1 here in order to just get the coefficient of solution, x3. That's what we did here by multiplying row 3 by minus 1, gets us a solution row. So minus row 3, 1, 1, 1, 1. 0, 1, minus 1, 2, 0, 0, 1, 1. So then this represents a triangular matrix. And that triangular matrix can be easily solved by back substitution. These arrays, I guess I've said this, but these arrays are called matrices, and we use them in a number of ways in here, but this is the first way we'll use them, is in solving the equations. There are permissible operations. This word permissible means doing something to this array that doesn't change the values of its value as representing equations and equality. So this is an equality, and there are 3 of them. The one that's used often is add a multiple of one row to another. This represents adding a multiple of one equation to another, equals added to equals. Multiply a row by a non-zero number. It's multiplying both sides of an equality by a number. We did that here when we multiplied both sides by minus 1. And another one that we didn't use here, but comes in handy, you can exchange 2 rows. So exchanging 2 rows just means you reorder the equations, but has nothing to do with the solution. So these are called the 3 elementary row operations. I ask these point blank on a quiz and a test. I will just say, what are the 3 elementary row operations? And this is what I want. There is one thing to remember here, and that is this word. You don't add rows together. You add a multiple of one row to another. This keeps track of the order of things, which is important in solving equations. So these are the permissible operations. And the net result here of doing this is a triangular matrix for what we've done so far. If the matrix just has an echelon form, that's what you get here. So tomorrow in class, we will practice. I'll give you several systems of equations, asks you to write the matrix form, and then to hand reduce the matrix in this way, and then read off the solutions. So here we can read off the solution x3 equals 1, and then we have to back substitute into this one. X2 minus 1 equals 2, so that says x2 is 3. And then x1 plus x2 plus x3 equals 1. So x1 is minus 3. So there's the solution here. But tomorrow we'll see what happens when you have a free variable and so on, how you get those. So take a look at this. You might look through the solutions that I put up for the problems, and I will see you tomorrow morning.